So lesson 1.4 is going to start talking about angles. So we have a little bit of vocabulary we have to go over first. So it says a blank is a part of a line, so it is a ray. So a ray is a part of a line. It has one endpoint and extends infinitely in one direction. Rays are named by starting at the endpoint first, and then any other point on the ray. So again, in the particular case right here, M is the endpoint, and then you can pick anything going to the right on that line. So ray MP, ray MO. You can use the ray symbol, which is a line that only has one arrow though, because it's only directed in one direction. But you have a few options there, but you have to start at M. You can't start at O or P. So if you choose a point on a line, that point determines exactly two rays. These are called opposite rays when we're talking about a line, that is. Okay, so opposite rays. So since both of the rays share a common endpoint, the opposite rays are collinear. So let's just say if we pick point J, we go to the left, and then we go to the right. Okay, so if we start here, going this way, we have JH. Going this way, we have JK. They are both two rays that start at the same endpoint, which is J, which means that they are collinear to each other. Okay? All right, next set. So it says an angle is formed by two non-collinear rays that have a common endpoint. The rays are called the sides of the angle, and the common endpoint is the vertex. Okay, so again, we have, when we talk about an angle, the little middle letter right there, or the common endpoint of the two rays, is our vertex. And then it is made up of two rays, which are considered to be the sides. When we name an angle, we use 3 letters. That is most important. Okay? So when you have 3 letters to use, you have to make sure that you're using. Do not use a single letter unless that is the only option that you are given. Okay, so when we talk about an angle divides a plane into 3 parts. You can either be on the angle, you can be inside the angle, or you can be outside the angle. And it is 100% location based. So if it's on the angle, then it's on the angle. If it's inside, if we were to close like a mouth of an alligator, think of it like that. If it falls inside of that, it's considered in the interior, and if it falls on the outside or behind the angle, then it's considered to be in the exterior. So let's just practice with an actual diagram here, or a map of the high school. Not necessarily our high school, but we're going to practice identifying parts because it's important to be able to pull stuff from a diagram. So it says name all angles that have B as a vertex. So remember, a vertex is the middle letter of an angle. So there's lots of different angles that we can name. So B is right here. So we can call, if I'm going to use letters, I need to make sure that I'm using 3. So I can go with this direction, ABD. So I can call it angle ABD. I can flip that and say angle DBA. I can also go the other way. I can say angle DBC and angle CBD. But you also notice that there's 2 numbers that fall at that vertex within those angles that we were talking about. So at angle ABD or DBA, we have angle 1. And at angle DBC or CBD, we have angle 2. So you have 6 possibilities. You only have to give 1. Okay? For number 2, it says name the sides of angle 3. So here is angle 3. You have to follow those out. C is at the same location that 3 is, so C is considered to be the vertex. Therefore, the 2 sides of that angle, starting at C, would be CB and CE. Okay, if I pull that diagram out a little bit, here's B, here's angle 3, here's C, and here's E. So if we are talking about angle 3, C is the vertex, and CB is one side, and CE is the other side. So that's where those 2 values come from. For number 3, it says, what is another name for GHL? So you got to follow the diagram. So we're going from G to H to L. So you can either say angle, flip the letters, LHG, again, H has to be in the middle, or you could say angle 7 because there's a number there. For 4, it says name a point in the interior of DBK. So we need a point that is in the interior of DBK. So again, if I redraw it, say like this, here's D, here's B, then you have C, then you have K, then you have L. From C, you have E out here. So again, we are looking for something in the interior of this angle. So think of this like an alligator mouth that's going to close. Here's your two sides. If we were to close that mouth, what point falls within that? And that would be point E. So number 5 says, what is the vertex of angle 5? So you look at angle 5, it's between two lines, and you decide what letter is right in that same location, and 5 is right next to C. So C would be the vertex. And for number 6, name a point in the exterior of CLH. So if I were to, say, trace that a little bit darker, here's C to L to H. So interior is if we were to close that mouth. Exterior is if it would fall outside or behind that particular angle. And again, those lines have to be extended forever. They go on forever. But the 2 points, if I continued this line all the way up, and if I continued this all the way through the auditorium, that's the angle we're talking about. If I close that, that would be considered interior, but I need something sort of behind it. And that would be either point D or point E, because again, they fall behind where the angle is. All right, so now when we talk about angles and measurements or degrees, we have right angles, we have acute angles, and we have obtuse angles. So an angle that's considered to be right is equal to 90 degrees. An angle that's acute is less than 90 degrees. An angle that's obtuse is between 180 and 90. So it's bigger than 90, but it's less than 180. So again, a right angle equals 90. An acute angle is less than 90. And to be honest, we can also add the component. It has to be bigger than 0 because it can't be negative. And an obtuse angle is between 90 and 180 for those parts. All right, so let's practice a little bit. The book is going to reference a protractor. You do not need to worry about a protractor. You just need to worry about being able to identify or classify the angle based on its looks. So it says for number 9, AFB. Well, here's A to F to B. So I'm going to use colors for all of these. So number 9 is in blue. That angle definitely is less than 90 degrees. So that would be considered an acute angle. Next one, CFA. C to F to A. So that's our green angle right here. Now, you see this little box on the right-hand side. That little box means you got to add the box on the left-hand side. Okay, but CFA, that looks to be about a right angle. Straight up and down, perpendicular to each other. So that would work. All right, AFD. So we have from A to F to D. Well, if we said the green angle was a right angle and D went further beyond that, then that means this one has to be an obtuse angle. And then the final one we have here is CFD. So that's this guy right here. So CFD, that's definitely little. Think of acute, it's like acute angle. So that would be less than 90, so that's acute. So now we've talked segments in terms of congruence, but when we have angles with the same measure, they're considered to be congruent to each other. An array that divides an angle into two congruent angles, it is called an angle bisector. So just like we had a segment bisector for a segment, we now have an angle bisector for an angle. So we have 2 examples left. So it says, and we're going to fill the picture in because that's very important. So up here in the directions, it's telling us that KN bisects JKL. Well, here's KN, and here's JKL. So when something bisects, when this segment bisects, it cuts it in half. So I know that this angle is equal to this angle. That is the crucial part. Now, if we look at the information in 13, we can fill in what we have. So JKN, so from J to K to N is 8x minus 13. And from N to K to L is 6x plus 11. So before we even look at what the question is asking, if you look at that, we can see that this angle, let me change the color, we see that this angle right here is equal to this angle right here, which means we can set those two things equal to each other. So 8x minus 13 equals 6x plus 11. If I bring the 6x over, I get 2x. And if I bring the 13 over, I get 24, which gives me x to be equal to 12. Now the question, though, wants to know what JKN is. So angle JKN is equal to 8x minus 13. So we're going to plug in 8 times 12 minus 13. We use a calculator, and we get 83 degrees for our final answer. Okay, but the crucial part is identifying the bisecting piece, because that is important. So 14 has the same picture. This ray is again bisecting this angle, so I'm going to add that in there. And now we know that JKL, careful now, so JK to L, that's the whole entire thing, is 9y plus 15, and JKN is 5y plus 2, so that's going to go there. So the other bit of information that we can add is if we know these two angles, this one and this one, are congruent to each other, well, if this one is 5y plus 2, then we know this one is 5y plus 2. So the difference between 14 and 13 is we had the two smaller parts. With 14, we have the bigger angle, and then we had one of the smaller ones, but we can associate it to the other one because we know they're equal. So if we set this up, we have two angles, two little ones, 5y plus 2 plus 5y plus 2 equals the 9y plus 15. So we get 10y plus 4 equals 9y plus 15. Bring the 9y over. Bring the 4 over. We get y to be equal to 11. And then we are finding JKL. And JKL is our 9y plus 15. So we're going to do 9 times 11, 99, plus 15. And that gets us 114 degrees. Okay, so again, on the homework tonight, just make sure for 30